Hello everybody, and welcome to the fifth part of the Deep Rising Introductory Training series. Okay, and in this video we're going to start looking at the solvers in depth, and we're going to start with the euphoric solver. And like I said in the previous videos, Deep Rising version 2 has three main solvers, called euphoric and Proxima and arena solver. Only two of them are fluid solvers, the euphoric and Proxima. So we're going to have a look at the first one, the euphoric solver, which is the most powerful fluid simulator between the two. Okay, and we're going to start looking at each individual setting. We're going to dive into what they mean, and hopefully that'll make your life easier. But in this video, we're just going to look at timing, time steps, and substeps. This is very important. This tab actually is the same for all three of the solvers. Okay, so we won't cover this again. I'm just going to look at it just once, and you can apply the same concepts to the other two solvers when it comes to timing, time step, and substeps. Okay, so let me just play this little simulation here. Actually, I've done a preview. So if I say play preview, what I want you to pay attention to is the speed of the simulation. Okay, so at 25 frames per second with the default settings of a time step of 0.001 and substeps of 6, we get that. Okay, so I'm going to try to explain this without it being technical, though. Okay, so a time step is a way for us to just to solve a really complex system in in mathematical terms. Okay, but as an artist, you don't really want to know about all the details about that. Okay, and this is actually about accuracy and the size of the particles. Like we said in the previous videos, all particles are 2 centimeters by default, and you can't change that. Okay, so let me actually show you something here. So I'm going to put up the time step, and I want you to look at the spacing of the particles in between. So if I hit simulate, you can see the gap is now bigger. Okay, and that directly relates to how SPH actually works. Okay, so let me try to explain this without making it sound complicated. So let's say we need to walk somewhere, and it's exactly 10 centimeters away. Each step we take will take 1 centimeter. So in 10 steps, we're going to reach our destination, 10 centimeters. Okay, so let's say those 10 centimeters is our time step of 0.001. Okay, that's our default move. We're going to move at that speed. Okay, that's normal. Okay, so but let's say we're moving too fast. Okay, let's say we want we're very, how can I put this, very picky about the way we walk. We're gonna walk 50, I mean half of a centimeter. Okay, I mean, yeah, half of a centimeter. We're gonna sorry, I should have said the meters. Actually, we're gonna walk half of a meter, which is 500 centimeters. So we're gonna walk half a centimeter. It's gonna take us 20 steps to get to 10 meters. Okay, so what's going to happen is it's going to take us, what we're going to say is the same time it takes us to walk 1 centimeters, it's going to take us to walk 500 won't take the same amount of time it takes us to walk 1 meter. It's going to take us 500 centimeters. It's going to be the same time. Okay, half the meter, it's going to take the same time. So it's going to take us twice as long to reach the what do you call this, the destination. Okay, and the smaller steps we take, it's going to take longer and longer and longer. But the advantage of moving slower is we're more accurate. We're not going to miss a step. We're going to walk really slowly, and we're going to cover the domain, the steps. We're going to actually, our feet will be closer together. We're going to touch every part of the floor as we walk, and that's really good for simulations because they're going to be more accurate, and they're going to be, they'll look more interesting, and you have less penetrating and stuff, but still slow. Okay, and the only guideline I will give you for deep rising effects is that 0.001 is the ideal starting point. Okay, and you shouldn't actually go over a time step of 0.02. It's possible, but your results will be, I can't guarantee it's not going to be stable and might not look well. And you might be able to get get away with it with really, really slow simulations, but advisable 0.002 should be your maximum, okay? And so, since, let me just put this here 1 second. If I drop the substeps, I'm going to talk about substeps next. So, I've dropped the substeps to 1, and you've noticed the simulation is now slower. Before, we had a bunch of particles moving faster. So, let me go back to the analogy of walking again. So, like I said, walking 1 meter is the same as walking half a centimeter, okay? Now, let's say we're walking half a centimeter, but we still want to reach 10 centimeters at the same time as walking 1 meter. What can we do? So technically, we could take 2 steps in the same amount of time, right? So we could take 500 centimeters and 500 centimeters in the same amount of time it took to take the same 1 meter. In other words, we're going to take twice as many steps, but we're actually going to reach the 10 meters in the same amount of time as walking 1 meter per step, right? That's what substeps allows you to do. So we're going to walk 6 times per frame at 0.004, you know, or 500 centimeters for that 6 times, okay? That will actually make things move really, really fast, okay? It's actually an illusion, but that's what you want. And the only disadvantage of this is it's doing the calculation 6 times, but you're getting you're getting the speed, and you're getting things that look animatable, pleasing in the viewport. Okay. So for those people who have a hard time picturing what time steps are, you've got frames per second. Okay. And by default, I'll just simulate, and you see what you get with this. It's really fast. It's moving at 30 frames per second. And if we play this out, it's actually going to look the way it is. Okay, let it just run through. You can see the particles are moving everywhere. I'm sure going to run out of 500 particles, because that's how many particles we set the limit for the particles. And so it's running, and done. And we can just make a quick preview of this, so we get a feeling of how it actually look when we render it out. And oh yeah, of course we can actually put it at 30 frames here. And if we press play, this is what we get. We get a really, really rapid simulation. Okay? And now the good thing about the frames per second is it doesn't matter. So if we drop this to 2, okay? So remember, changing time steps, if we use the substep order, it changes the speed of our simulation. But the goodness about frames per second is you don't have to worry about that anymore. You just tell it the time step you want, it's going to calculate the speed automatically for you. So whether it's 0.04, 0.03, it's going to calculate the how many substeps you need to keep the frame rates per second, okay? So we'll just let this run out. So as you saw before, by decreasing the substeps, it became slower. But with this way, if you like working with frames per second, it's just going to work. This will be the last demonstration before we move on to the next video, just to show timing in deep rising effects. Oh, and as you've noticed, like I was saying, the spacing, since we've dropped the time steps, the spacing is really small now. It's more accurate, actually, as I like to say, it's more accurate now, right now. And it will behave more like a fluid the lower the time step is. So, and like I said, the maximum, it should really be 0.002. Okay, so let's just make a preview of this. And you will see it's going to look roughly the same, but with more particles, of course. 1 second. And put this at 30. And play. So we've got the same, the same frames. It's moving at the same speed with a different time step, okay? So you don't have to worry about substeps anymore. So it depends on what your preference is. If you prefer using substeps, use substeps. If you prefer thinking in frames per second, you can use frames per second. Okay, thank you for watching, and see you in the next video.